Hello and welcome everyone to the Cisco Support Community. Today we present a live Cisco Support Community Expert Series webcast. During our event today, our topic will be single-site and multi-site Flexpod infrastructure. My name is Dan Gerson and I'm the Program Manager for the Cisco Support Expert Series webcasts. Our expert joining me today is Hasib Niazi. He's a technical marketing engineer in Cisco's data center group specializing in security and data center technologies. He holds a CCIE in routing and switching. Welcome, Hasib. Joining Hasib is Derek Huckabee, a technical marketing manager, also with the data center group, and David Clem, a senior reference architect in Netapp's infrastructure and cloud engineering team. He's also one of the lead architects of the Flexpod, Flexpod Express, and secure multi-tenancy solutions developed by Cisco and Netapp. Now I'd like to briefly outline the format for today's Expert Series event. Hasib will start with a short presentation on single-site and multi-site Flexpod infrastructure for the first 25 minutes of the program, and then we will dive into the live question submission for the remainder of the event. During our live presentation, you may submit questions to be answered by Hasib and the team of Cisco and Netapp technical experts using the Q&A box on the right side of your console. The team of technical experts is well versed in today's topic, so please begin posting your questions now to give us the best chance on answering them. If you experience any technical issues, please post those questions into the chat. We will be asking polling questions during today's webcast, and we highly encourage you to participate by answering them. You may download a copy of today's PDF presentation using the link in the chat window. Now, let's get started with today's event. We'll start off with a polling question. How many of you know about Flexpod? A, I have heard about Flexpod, but I'm not sure what it is. B, I know about Flexpod, but do not know about the various flavors of Flexpod. C, I'm considering deploying a Flexpod in our environment. Or D, I'm running Flexpod in our production data center. Take a moment to answer. Don't forget you can submit your questions at any time during today's webcast. Please do that early so we can make sure that we can get to answering them live during the webcast. Now I'd like to pass the mic over to Hasib to begin his presentation. Hasib?
Thank you, Dan. Hello, everyone. My name is Hasib Niazi, and I'm a technical marketing engineer in the Cisco Data Center Group. Been with Cisco for over 14 years now, and my current area of focus, as you may have guessed, is Flexpod infrastructure design and validation. Our team works very closely with the Netapp team, as well as a number of other sisters teams within Cisco, especially our Nexus switching team. We develop, validate, and deliver the Flexpod infrastructure designs. I will take this opportunity to introduce our question managers, David Clem and Derek Huckabee. David is joining us from Netapp and works very closely with us on the Flexpod designs. And Derek is from our Nexus switching business unit, and just like David, we all work very closely together. My immediate team in Cisco focuses on developing the Flexpod infrastructure. But my extended team, the data center group, solution group, we work on delivering various applications and solutions on the Flexpod platform. Some of the applications which are validated on the Flexpod include applications such as Microsoft applications, Exchange, SharePoint, and what else, SAP and Oracle. Our team also works on validating big data solutions such as SAP HANA on the Flexpod infrastructure. So, all in all, we develop the platform, we hand it over to our application teams, and they validate applications on this architecture. Going over today's agenda, today's presentation will cover Flexpod overview and high-level details of both single and multi-site Flexpod designs. We want to cover various design components, design details, and some of the drivers behind some of the design decisions which we made along the way. We will keep our discussion at a design level, which means at a higher level, and won't be going down into the configuration details of the individual components. We do have various references to some of the validated design guides which cover these areas in detail, and I'll be pointing them out as we go along. Let's start with the Flexpod overview. So, motion to converge infrastructure. Flexpod is an example of a converged infrastructure stack, or integrated compute stack, or ICS as we like to call it. I think before we start discussing Flexpod, it was fair to go over why the Flexpod was developed and what business cases does it address. As you all know, the legacy approach to building a data center infrastructure is to start with selecting the components, putting them together in the lab, validating the architecture, essentially building all of the data center yourself, and then running the validation tests and whatnot to make sure everything works according to your specifications. Around the 2009 timeframe, based on a lot of customer and partner input, the idea of this converged infrastructure was perceived. And many of you probably are already familiar with this. And as you can see on the slide, a hefty TAM based on a number of studies helped a lot in driving this idea into reality. And Cisco launched a number of initiatives alongside our partners such as Netapp and EMC and some of VMware and some of the other vendors to come up with not only a single SKU to order a pre-valid data center pod, but also create all these validated infrastructure designs such as vBlock and Flexpod, so that customers can just take the validated design and deploy it and hopefully not worry about nitty-gritty details of setting up the data center. Over the last few years, we have seen the infrastructure designs not only reduce time and cost to deploy these services, but also reduce the operational expenditure because of inherent standardization. Now, Flexpod infrastructure is, as I said, one such design. It's an integrated compute stack, converged architecture. Provides a pre-validated architecture for deploying both virtualized and non-virtualized workloads. Most of the customers equate Flexpod to virtualization, but that's definitely not completely true. We do support bare metal installs for Red Hat and Windows servers and whatnot. And as the name Flexpod suggests, the Flexpod designs are flexible. Customers have a choice of platforms and technologies. You can choose between the rack-mounted unified compute systems. You can choose between Nexus 7000 or 5000, and you have a choice of Netapp FAS controllers, which you could choose. So three main components of Flexpod essentially are compute, switching, and storage. Compute, as you can see, is the Cisco Unified Compute Systems, both the B series, which is the Blade chassis, as well as the C series. From switching perspective, we started with the Nexus 5000, but now we have included Nexus 7000 to the Flexpod designs for the increased scale and some of the other features which 7000 brings to the table. And we have the Netapp FAS. We cover all the 2000, 3000, and 6000 lines. The latest ones being the 2232 and the 6200 series. And as mentioned earlier, we work very closely with the Netapp teams, with our switching business units, and we validate these architectures and publish the design guides so that inherently it reduces the risk for the customers. One thing which we wanted to point out was once you validate a Flexpod architecture, you know how a pod behaves, you know what the scalability and performance of a particular pod is, and you know how to set up a particular pod. You can just replicate that pod over and over again for increased scale. And with all the validation and the predictability of the scalability, essentially you can increase the scale depending on how much of a scale do you need. Some of the studies which we have done over the past, and I mean, much of this is based on the inputs from both our sales force as well as from our partners. Let's go over a traditional data center design process. Essentially, you have to not only procure the equipment, you have to do the planning, you have to select the right components, then come up with the design, put the design together, deploy the different components which you have purchased, and then validate and test them. What Flexpod strives to do is, or what we strive to do is, we work with our partners, the storage partners, and we try to pre-validate most of this infrastructure. We give you recommendations on both the performance and scalability, and we use the best practices from both our partners and for our internal products. And we provide you a validated design guide as well as a reference bill of material so that you can actually deploy a pod in your data center. And what we found is we can do that at least 50% faster than what you would have done if you did not go down this validated route. So we reduce the planning time, procurement time. We can't do much over there, but since it's a single SKU, you know what to order. So there is definitely some efficiency there. The design is already laid out for you. The deployment time is reduced. And if the validation is already done, I mean, you just have to do a cursory check on your own applications, and basically that's how this efficiency is derived. Some of our channel partners essentially deploy pre-provisioned Flexpods. So essentially they build them in-house, validate them, and then they ship the pods off to the customer data center locations. And if that's the case, basically the time is reduced even further. Most of you might already know this, but Cisco Validated Design, or CVDs, is developed after validating some of these architectures, and it's not limited to Flexpod. I mean, we create CVDs for a number of other architectures and designs as well. But essentially, at the end of the day, when we validate a particular design, we come up with a deployment guide which covers not only the configuration of various components, but also how these components are cabled together. So essentially, if you pick up a Flexpod CVD, let's say for a Nexus 5000 base design, you would know what components are part of the Flexpod. We would tell you how to connect them together. We'll also tell you how to configure them in a step-by-step way. And by the end of that CVD, I mean, after you go through those 100, 200 pages, you would have a running Flexpod with vCenter and ESXi and everything installed. So essentially, you are ready to deploy your virtualized or bare metal workload at that point in time. Just to give you an example, I mean, when I first joined our existing team, this is how I learned. I mean, I took a CVD for an Nexus 5K based design, and I just went through the whole process. It took me about a week with I did not know Netapp that well. I mean, I had some experience with VMware. I definitely knew the switching part. But within a week, I was able to set up the whole Flexpod. And it was working, and it was according to the best practices of both Netapp and Cisco. And depending on your experience with some of these products, I mean, your time could be less than this or more than this. But essentially, the point I'm trying to make here is that if you go with the validated Flexpod designs, follow the CVDs, essentially, I mean, you can deploy very, very quickly, and you don't have to worry about some of the pitfalls because we've already worked through those when we validated this solution with our partners locally. This leads us into the evolution of the Flexpod designs. As I mentioned, somewhere around 2009, 2010 timeframe, the idea for a Flexpod was conceived. The first Flexpod, and I'll cover these designs in detail as we go along, but the very Flexpod was developed for VMware. From that point on, we developed a Flexpod and deployed Red Hat Enterprise Linux on it. We did secure multi-tenancy design for the private clouds. We introduced Nexus 5000. We introduced technologies such as FCOE. We added the Netapp clustered data on tap. And then we moved into the Nexus 7000 addition to the Flexpod. And along these, this is what I'm talking about, basically the platform. And along this whole line, we had various applications validated on the Flexpod, and as well as Microsoft Private Cloud solutions, which were validated. For us, the next thing coming down within a month would be the Multisite Flexpod. So essentially, typically, Flexpod has been a single pod in a single data center. Now we're trying to increase the high availability to some extent, do the disaster avoidance by expanding a Flexpod across two geographical locations within a metro domain. And I'll cover that in the upcoming slides. So we have a polling question number 2. How many of you use Cisco Unified Compute System, or UCS? And some of the options are: you don't know what UCS is, I don't know about UCS, but I'm not sure if I need it, I'm evaluating UCS and work on it on a daily basis, to I have production workloads running on UCS. While you're answering the polling questions, let me just move on to some of the design requirements behind Flexpod. When we started working on Flexpod, we realized that what we wanted to deliver, or what we perceived as a Flexpod, was very, very similar to what Netapp thought of the Flexpod. So essentially, let me just build this slide up. From the Cisco design principle, we wanted a design which supports high availability. We wanted a design which supports a number of protocols, not only on the Ethernet side, but also on the fiber channel side, including fiber channel over Ethernet, etc. We wanted to utilize our switching platforms, which were highly scalable and the state-of-the-art, built for the data center. In our meetings with Netapp, their principles, as you can see, are pretty much the same. They wanted high availability, flexibility in the protocols to access the controllers, as well as they wanted to deploy their data on tap for scalability. So essentially, using these design principles, we built the Flexpod, which provides all this functionality at both the switching, compute, as well as on the storage layers. So the name Flexpod sometimes could be confusing. It's a flexible pod. Some people think they can take UCS, they can take Netapp, certain models, maybe older equipment sitting in the warehouse somewhere, put them together, and they've got a Flexpod. To clarify, Flexpod is definitely flexible, but then there are some requirements, some core requirements for the Flexpod. And some of the required components for the Flexpod are definitely have to have a UCS chassis or a rack mount chassis, which is managed through the Fabric Interconnects or UCS Manager. We want to have at least redundancy at the Fabric Interconnect level. We want to have redundant Nexus switches. We want to have redundant FAS. Some of the flexible components are, once you use the items on the left-hand side to build a base Flexpod model, you can enhance it. You can increase the port count. You can buy bigger switches. You can deploy 5K. You can deploy 7K. You can deploy different models of these switches. Same thing with FAS. I mean, depending on the requirements, I mean, you could go with the 2200 series or 3200 series or a 6200 series. Port count I already mentioned. Same thing is true for the disk types, their count and sizes, and add-on cards and modules, etc. We just received our result for our polling question, and it seems like 50% of the people actually have production workloads running on the unified compute system, which is great, and 20% of the people are actually evaluating it. Some of the people, 16%, don't know if they really need UCS, and hopefully we clarify that. But I mean, it's for us, it's a pretty good statistic. I mean, at least 70% of the people attending have Flexpod in production or are evaluating it right now. Thank you for that. Let's move into the Flexpod designs. And as I mentioned, I mean, we'll go into the Flexpod designs one by one. And this kind of helps you see the evolution of the Flexpod as well as what's out there. And then towards the end of this presentation, I mean, we have a slide which provides links to all the Cisco validated design guides for each and every one of these designs. And our intention was, I mean, within this hour and a half, we wanted to cover both the design details as well as some of the factors which led us to these designs. But for detailed information, I mean, we wanted to point you to the Cisco validated design, or if you have any specific questions, I know we have asked the expert starting on Flexpod following this event. I mean, you're more than welcome to ask your questions there. So very first model of Flexpod, we used a UCS B series connected to Nexus 5548 switches. From UCS, we have dedicated or the converged ports going down into the fabric interconnects. We all know that. Fabric interconnects connected to the Nexus 5000 for Ethernet, separate than the fiber channel. So essentially what you're seeing is we have a port channel for fiber channel going down to the Nexus 5548 switches, and we have a VPC going on for the Ethernet traffic going down to the Nexus 5548. Same thing is true for the Netapp filers. I mean, we have separate SAN and the LAN ports. Using this architecture, what we did was we did not want to use the MDS switches to keep it a slightly lighter weight. And that's what we did. I mean, 5548 was being used for providing the SAN functionality as well as the LAN functionality. We ran, as I said, I mean, we maintained the separate SAN A and SAN B going out to the Nexus 5548. The very first design, I mean, we started with this architecture, and then we realized, I mean, some of the customers actually need something smaller than what we delivered in the very first phase. And that's why an entry-level IP-only design was built. Looking at the entry-level IP-only design, I think one thing which probably stands out right away is that we don't have a UCS B series chassis in there. We have the UCS C series chassis connected through the FAXes, Nexus 2232 fabric extenders, and they connect down to the fabric interconnects. One thing which I mentioned earlier, and I don't know how many of you caught it, was that we, in a Flexpod design, we want UCS Manager to actually manage all the compute. So that was the reason why the C series servers, I mean, you see them deployed through the FAXes and they connect to the Nexus UCS interconnects, fabric interconnects, so that we can manage these servers through the UCS Manager. Now, with the single wire management functionality, I mean, some of the cables can be reduced even further. But essentially, in this design, I mean, if you don't need more than 4 to 6 servers, essentially you don't have to buy the chassis, and this design was validated for the C series. Further, since it's an entry-level IP-only design, we decided not to include SAN into this FlexPod. And that is why, you see the only connectivity between the various devices is LAN-based or the IP-based. While that's all great, you can definitely use the NAS functionality on the and the NFS on Netapp controllers. The boot from SAN could not be performed, especially using the FC or FCOE. So we use both iSCSI boot as well as the Pixie boot in this particular design. So essentially, if you want stateless compute, you have option to boot from either iSCSI or through Pixie, but booting over a fiber channel definitely is not possible. Many of our customers actually still install ESXi locally on the local disk on some of these blades. So essentially, while many have started using the stateless compute and booting from SAN, some of the customers feel comfortable just installing it locally, and if the blade fails, essentially they just migrate the workloads off to the other ESXi servers. In the virtual environments, it kind of works great. Going along the same lines, it was only natural that we have tested with Fiber Channel and with all the Cisco's drive behind Fiber Channel over Ethernet. We introduced a design which has FCOE introduced in the design, so that we can actually move to a converged architecture. And the first design which we tested in FlexPod for the converged architecture essentially is based on a UCS B series connecting to the Fabric Interconnect's converged ports, C series connected to similar fashion. From the Fabric Interconnects, we connect to the Nexus 5K switches for LAN as well as for FCOE. And what you probably have noticed is we still carry the FCOE traffic separately on a separate port channel. We're not carrying it from the Fabric Interconnect down into the Nexus 5548 switches. We have a virtual port channel going down for the LAN traffic, and we have a dedicated port channel going down for FCOE. And there are a couple of reasons why we do that. One, some of our partners and customers kind of wanted dedicated bandwidth for the SAN. So essentially, providing a separate port channel down gives us that flexibility that your LAN and SAN traffic doesn't mix. And even a bigger reason was we wanted to maintain the SAN A and SAN B separation. And that was the reason we did not actually want to carry this traffic over a VPC, because with VPC, you don't know where your traffic ends up. So essentially, if you want to maintain the segregation and you want enough bandwidth for your SAN traffic, you want to keep these separate, and that's exactly what we are showing over here. On the Netapp side, essentially, we have, the way Netapp handles FCO traffic, FCOE, as well as the LAN traffic over the ports is slightly different than how Cisco handles it. And for us, we could maintain the SAN A and SAN B functionality over the same links, even though they were connected through VPC. So essentially, the LAN traffic utilizes the VPC, but for the SAN FCOE traffic, we use dedicated links going up to the SAN A and SAN B switches. So this design kind of maintains that segregation as well as provides you the bandwidth you need. One thing which I kind of did not highlight, but it was in the title. The last CVD which we did was basically with Netapp 7 mode. At this point in time, we wanted to increase the scale of the FlexPod. So if you remember, I mentioned that FlexPod scalability could be horizontal, which meant you could deploy a FlexPod and then you just deploy another FlexPod, third one, fourth one. You can increase your scale horizontally. But what we wanted to do was, we wanted to actually introduce newer technologies so that even a single FlexPod design could be scaled higher. I mean, if you don't need to buy all this extra equipment because of the power and space requirements, I mean, the base infrastructure should be able to scale as high as we could. And this is where we actually introduced a couple of new things. We introduced Netapp's cluster data on tap, and we also introduced the Nexus 7000 for the increased scale from the Cisco side. It goes without saying, I mean, as the UCS new blades and the new processors come in, I mean, we constantly keep on upgrading them. When we started Flexpod, I think we were testing the M1 servers. Now we are up to M3 servers and the newer models. So compute keeps on changing, but and same thing is true for the FAS. I mean, we tried different size FASs, but we at the same time we want to introduce a different class of switch, or we want to introduce a completely different technology such as cluster data on tap, so that we can increase our scale as well as performance. With cluster data on tap, I mean, the performance. Let's start with the scale increase. You can have multiple HA pairs, and you'll see that in a second, which increases your scale. I mean, you have more. You can actually add more controllers and make them act as a single system. And when you add more controllers, definitely the IOPS goes up, so your performance actually increases. So just to reiterate that idea, I mean, typically in a 7 mode, Netapp controllers are running as an HA pair. So active standby, not the active standby, it's basically active-active. I mean, you can serve your data stores from either of these controllers, but if one of the controller dies, the other controller takes over for any data stores which were being served by the down controller. So that's the active-active pair in the 7 mode. So cluster data on tab, or the cluster on tab, essentially has the same concept. You still have the single failover pair. So essentially you take an active-active pair, or you take 2 active-active pairs, and you have this system which is 2 controllers backing up each other and another 2 controllers backing up each other. So you have these 2 units. Now what you want to do is you want to actually take these 2 units and make them into a single system. And this is what the cluster on tap does. Basically, you connect all these different controllers on a 10 gig backbone where they can all talk to each other. And by combining this HA functionality with this backbone connectivity, you essentially can you can deploy this system as a single system with a single namespace. What we did over here was we increased the scale, but I mean, we did not change the manageability. I mean, you're still managing it as a single system, which is the cluster data on tap system. For the cluster interconnects, that 10 gig backbone, it's supported on a number of platforms. I mean, Nexus 510, 520, 5596 platforms. In our validation, we typically use 5596. That gives us opportunity to expand. I mean, if you have a limited set of controllers, you can select a smaller platform. But with 5596, I mean, it can let you scale to the limits of the cluster data on tap. The way you increase the scalability is essentially now that you have more controllers, you can add more disks. You can add bigger controllers and make them part of that single namespace, which we mentioned. And you can keep on adding more HA pairs as you need. So essentially, you can do horizontal scaling. You can do some level of vertical scaling. And by combining all this into the single system, essentially your storage system can scale to your application needs. Let me just build this slide before I talk about this. Essentially, just to give you an example, Flexpod can scale really high depending on which switch you select, what kind of servers do you have, are those half-width servers, full-width servers, and whatnot. Plus, now with the capability of adding fabric extenders and adding the rack mount servers, your scalability is tremendous. Plus, a lot of applications which you're running, I mean, most of them are data intensive, especially if you go down to some of these new cloud-based applications. So in order to keep up with this growth in the number of blades you have, as well as the higher speed of each and every one of these blades, cluster data on tap essentially allows you to keep on expanding your IOPS, or the number of IOPS which you can support as you go along. And that's the kind of the idea which we are trying to portray over here. If you are using NAS-only functionality, you can actually go up to about 24 nodes. But if you want the SAN and NAS both, essentially, depending on which platform you have, I mean, we can scale up to about 8 nodes today. The next design, of course, after talking about the cluster data on tap, I mean, we wanted to introduce was the Nexus 5000 based cluster data on tap design. This design was fairly similar to the 7-mode design, except that, I mean, if you look at the storage side now, we have that 10 gig backbone connecting the controllers. I mean, we're only showing 2 controllers right here, but essentially, I mean, you can scale up as much as you can. The one thing which I wanted to point out was that the configuration on these 5596s, I mean, it's mandated by Netapp. They validate this clustered on-tap in-house, and they provide you the configuration template. So basically, you have to load that configuration on these 5596s or any other Nexus platform. And basically, after that, as soon as you make the connectivity, your cluster data on tap could be configured on the controllers. In this particular Flexpod design, we introduced some other features. One of the features which I'm highlighting here is single wire management for the C-series servers. Essentially, the reason I mentioned that is that if we were not doing the single wire management, essentially we were burning extra ports. Now, with the single wire management, I mean, you have if you have limited set of FEXs, I mean, you don't have to increase the number of FEXs. You can support almost twice the number of C-series servers because you don't need the management ports connected. And as before, I mean, this solution is all FCOE capable, and it's a converged architecture. The difference between the 7-mode and the C-mode, besides the configuration on the storage side, just looking at it physically, is fairly simple. As you can see, the only difference between the two designs occurs at the storage layer. The compute and the network layer are pretty much the same, but at the storage layer, we have additional switches providing connectivity between the cluster nodes. I mean, that's the only physical difference between the two modes. I mean, besides that, the physical connectivity and the physical configuration for the most part is the same. We talked about storage scalability, increasing the storage performance through the cluster on tap. It's only fair now we talk about the other thing which we can increase, and that would be our switching capability. And to do that, based on some of the, actually it was driven by the customers and by the partners. I mean, there were some specific use cases where they required it. Nexus 7000 was introduced to the Flexpod. When we say Nexus 7000, I mean, people think of this massive, big switch which takes up the whole rack, but that's definitely not true. With the introduction of Nexus 7004, something which we 7004, which we use in our validation. I mean, it's a relatively smaller box, not too big, and it provides us this additional functionality. It provides us not only extra ports if needed, it also provides us with functions such as OTV, which I'll be discussing a little later, as well as the in-service software upgrade, etc., so that you can upgrade your software with almost zero packet loss. So as I said, I mean, there were specific reasons why we introduced Nexus 7000, and I mean, the field was very appreciative, and they've been deploying the Nexus 7000 base designs now. The very first design with the Nexus 7000 was IP-only design. And just like the IP-only entry-level system, I mean, you can do the FC boot. Basically, you have to revert to iSCSI or Pixie boot for stateless compute. We are using the same virtual VPC concept, virtual port channel concept, with the Nexus 7000, same as what we were using with the Nexus 5000 in this design. The FAS controllers are configured very much the same. So essentially, if you really look at it, you take out the Nexus 5000, you drop in a Nexus 7000, you configure it appropriately, and now you have additional functionality for your specific workloads. Just a reminder, I mean, if you folks have any questions on any of the material which we have discussed so far, or any material which we will be discussing, you're more than welcome to just keep on answering the questions, and our question managers will be answering it. And I think there's some questions which I guess I can answer towards the end. So after validating or after coming out with the design with the Nexus 7000, which was IP only, the next step, as you must have guessed by now, would be to actually introduce FCOE to the design. So Nexus 7000 based design with 7 mode as well as the cluster mode with FCOE was the next step, and we have delivered CVDs on this. In this particular design, there are a couple of things which we want to point out. Nexus 7000 uses a virtual device context. I mean, if you're familiar with Nexus 7000, essentially a Nexus virtual device context, or VDC as it's called, is essentially carving out a separate router or a switch from within the 7K. With the latest SOUPs, I mean, we support up to about 8 virtual device contexts. One of those virtual device contexts is actually dedicated as a SAN virtual device context for the storage area networking. So our FCOE links essentially between the fabric interconnects and the 7K are terminated into the VDC. Same thing is true for the links between the Netapp and the Nexus 7000. We have a dedicated FCOE link going between the Nexus 7000 SAN VDC down to the filer, as well as up to the fabric interconnect, as you can see in this picture. Now we discuss some of the highlights of this design. How is this design a little different than the Nexus 5K based design? One of the difference is, as I mentioned earlier, I mean, we have a separate VDC for the SAN and a separate VDC for the LAN. On the LAN side, I mean, the configuration is fairly similar to Nexus 5000. You have the virtual port channel aggregating your LAN ports both up to the UCS and down to the Netapp filers. For the FCOE, the key difference is that in case of 5K based design, your filers, Netapp filers, actually were carrying the FCOE traffic directly on the same ports as the LAN traffic. So, I mean, if you remember, the ports going up from Netapp were converged ports carrying both FCOE and LAN traffic. In case of 7K, we need dedicated FCOE ports going up to the 7K. The commonality between the two designs, the 5K and 7K based design, is because we have the SAN A and SAN B separation in both the designs, and we maintain that over here. One of the reasons why we ran separate cables or separate links up to the SAN VDC was we always use port channels going between any device to the other device for the resiliency as well as to increase the bandwidth. Nexus 7000, there was a feature which actually is going to be released, or it's either released now or is going to be released in the near future, where you can actually do a port channeling on the converged port. So essentially, Nexus has a concept of a converged port where when a traffic goes from a device such as Netapp or Fabric Interconnect into the 7K, you can carry both FCOE as well as LAN traffic on the same port, which is so-called converged port. And when the traffic actually reaches 7K, I mean, based on whether it's a fiber channel over Ethernet traffic versus IP traffic, Nexus 7K associates that traffic either to the SAN VDC or to the LAN VDC. In our design, we wanted that functionality with the port channel, and that functionality was only supported on a single wire, so essentially single connection. So we decided that in the first phase, we would be okay with running dedicated ports for carrying FCOE traffic, but in the next iteration of this design, we would actually utilize that new functionality, which is the converged port channel functionality coming into the Nexus 7000. So I guess for us, the next step would be that this design has to be revisited, where we actually start using the converged ports on the Netapp side going up to the 7K. So the design kind of mimics the Nexus 5000 base design. With this, we move on to the multi-site Flexpod designs, and that brings us to our polling question number 3. Are you using a multi-site disaster recovery solution or DR solution today? Your options are: we do not require multi-site DR. We are using cloud for disaster recovery. We're thinking about setting up a disaster recovery site and are planning on using Netapp Metro Cluster solution. Or we are thinking about setting up a DR site and are planning on using non-Metro Cluster DR solution. Please take a moment to answer this question, and I'll move on to the multi-site design, multi-site Flexpod design. In the beginning of the presentation, I kind of hinted that typically Flexpod has been, and based on the number of designs which I've shared so far, you probably already have realized it's a single site, single pod design. What we want to do now is, we want the design to actually extend to multi-sites, especially in a metro geographical location, so that you have you can actually do some workload mobility. You can do some sort of load balancing if you have to. You can do disaster avoidance. If you have to do maintenance on one of the data centers, you can actually migrate your load to the other data center. So there are a number of advantages of actually moving on to a multi-site design. And it definitely, in your situation, it might or might not make sense. But we wanted to provide you the ability to actually go to 2 different geographical locations, or 2 different sites, 2 different data centers, even within the same campus, and still be able to take advantage of the validation which we provide with the Flexpod architecture. So polling results are in, and this time it's basically almost even distribution across all the 4 options we had. 1/4 the people don't require disaster recovery. 1/4 of them are using cloud. 1/4 of them are planning on using Netapp-based solution, and 1/4 are actually planning on using third-party, a non-Netapp-based solution. Interesting statistics for us. Thank you for that. We have gone through this architecture before, the Nexus 7000 based single site design. The reason I'm flashing this slide again is because our multi-site design, our multi-site Nexus 7000 based design is actually based on a single site design. What that means is essentially when we do the multi-site Flexpod, we use the Nexus 7000 based Flexpod design as our base architecture. So essentially all the basic configuration, the way you configure your Netapp filers, the way you configure the 7000, it stays the same. But what you do is you essentially now make sure that the components which need to be extended or which need to be added are essentially added to this design. What I mean by that is, let me show you when I move to the next slide. In a multi-site design, essentially, based on the last slide, some of the components are actually extended across the data centers. Some of the components actually double in number, where we have the same components in both the data centers. For us, the design goal was to, at the end of the day, to provide a system which looks and feels like a single system. What that means is, even though we have added components in there, let's start from the top. I mean, we have added an extra UCS domain because now we have two different UCS, pair of UCS fabric interconnects, one in data center 1 and another one in the data center 2. We have two pairs of Nexus 7000, a pair in DC1, a pair in data center 2. We have extended our Nexus 1000V across the site. We have extended the Netapp filers across the two sites by using their metro cluster technology. And what that means is we actually use the MDS-based switches and the fiber bridge switches for the filer to be able to connect to the local as well as the remote disk. So essentially, as I said, I mean, the goal is not to go over how the metro cluster is set up or how we add these more components in there. The goal is to actually show you what doubles, which means UCS as well as the switching, and what stays the same but gets extended, which is the Nexus 1000V as well as the Netapp filers. In order to achieve the design goal of making this system look like a single system, we introduced 2 or 3 new technologies to the Flexpod, which were not part of the earlier Flexpods. One of that technology is the UCS Central. Not sure how many of you actually have worked or know about the UCS Central, but essentially UCS Central allows you to manage multiple UCS domains as if it's a single domain. So in our case, both the Flexpod have, as you see, a UCS domain in each of the Flexpods, in each of the sites. We'll use UCS Central to essentially manage both these domains. Our policies and the profiles and everything else will be defined in the UCS Central, and that would be the portal for the compute manager so that he can log in and deploy a new server or define his policies and whatnot. So essentially, UCS Central gives you that single point to manage multiple domains. So that's how we solve the issue of 2 UCS domains introduced into the design and still keeping it as a single design. We also used OTV, or Overlay Transport Virtualization. So essentially, it's a Layer 2 extension technology which works across Layer 3 boundaries if needed, or over the Layer 2 extensions if you want to. And it provides you connectivity as if the devices on the left-hand side are on the same LAN segment as devices on the right-hand side. Why we want to do that? Obvious reasons. You can migrate your virtual machines from one side to another side without even worrying about the IP addressing changes and whatnot. So that was one of the most important criteria, that we should be able to just migrate our virtual machines from one side to another and not worry about changing of the IP addressing during this motion. And the other few advantages which we actually gather from this Layer 2 extension is that VMware vMotion can utilize it. The ESXi servers on both sides see the NAS-based storage as if it's attached on the same Layer 2 domain and whatnot. So essentially, OTV gives us that flexibility where we can not only migrate the workloads, but also the components within within the infrastructure see each other as if they are sitting on the same LAN segment. And one such component would be Nexus 1000V. So essentially, by defining Nexus 1000V active VSM on one side and the standby VSM on the other side, we wanted to make sure that they can talk to each other, and they talk to each other on Layer 2. So essentially, we carried that traffic over OTV as well. This design also utilizes some of the enhancements which were made to Nexus 1000V for this multi-site deployment. Specifically, if you guys remember, Nexus 1000V for the longest time did not support active and standby across geographical locations. But in the newer codes, I mean, that limitation was removed after a lot of testing and enhancements were made, especially during the split brain scenarios, where if the link between the two sites go down, I mean, how do you decide which VSM becomes active, and when they merge back in, then who takes over. So I mean, all those enhancements and rules were placed into the code, and we actually tested that as part of our metro cluster design as well. And we definitely can attest that Nexus 1000 V can be deployed as an active and standby across geographical locations, and after testing it or validating it in our lab, we basically made this part of our design as well. Essentially, using these technologies, we solve the issues of multiple domains and geographical segregation between the switching, as well as enabling vMotion seamlessly across the two sites. So at the end of the day, how does it look like? We try to showcase, I mean, the part of the slide which you don't see that clearly, the bottom side, that's basically the physical connectivity between the two sites. But when you logically look at it, essentially we are using the connectivity between the 7Ks between the two data centers. We are extending both the SAN A and SAN B across. We are extending the LAN across the two sites. And it seems as if ESXi servers are sitting on the same LAN segment, connected to the same SAN network, and connecting to the filers underneath. So, I mean, if it wasn't for the latency between the sites, this architecture would be as good as, or exactly the same as, a single site architecture. We also use the VMware VMSC design guidelines when validating this design. And some of the key design guides, some of the key areas of that design guide were that you have two sites and there is latency between them. So one of the design guides, and I mean, all of us can appreciate that, is you need to identify which virtual machines need to run on which data center. For example, in our case, we decided that our Active Directory 1 and Virtual Center and some of the applications, App1 and App2, would be running on the data center on the left, while AD2, UCS Central, App3, App4 would be running on the data center on the right-hand side. So left-hand side and right-hand side. After you decide which VMs are going to run where, you actually create the VM to host affinity rules so that under normal circumstances, your VMs actually stick to one data center or the other. And then you actually use the appropriate data stores in each site to actually host the hard disk of those virtual machines. So the idea is that if your virtual machines are running on the left-hand data centers, their disks should be on the data stores served by the controller on the left-hand side. And this is to avoid any latency across the WAN segment. This multi-site Flexpod design, I mean, I haven't gone into too much detail. I mean, if there could be a complete couple of hour session just on the multi-site design considerations and whatnot. But what we want to highlight here is, and I'm sorry about some of the lines which are actually missing in this build out. It's probably my Mac causing this issue. What we want to highlight is that our infrastructure is completely redundant. So we never wanted to get away from this redundancy when we moved to multiple sites from the single site. What I mean is that if one of the ESXi servers go down, essentially VMware HA, using all the affinity rules which we have, it actually migrates those applications running on that ESXi servers to one of the servers which is still up on the same site. So essentially, since your hard disks or your virtual hard disks are held in a data store on this side, your VMs will be restarted on an ESXi server on this side. In a similar fashion, if one of your switching node goes down, I mean, we have a redundant switching node which will actually carry that traffic. Of course, I mean, it will be more loaded than it was before, but I mean, we have a node there. If it's appropriately sized, we will be able to carry traffic without any losses. If some failure occurs at the metro cluster level, which means one of the MDS goes down, maybe one of your SAN path goes down, but essentially we still have redundant paths to carry that traffic. And if one of your Nexus 1000 V goes down for some reason, we have another Nexus 1000V, and that can actually take over as a primary VSM. So the point we're trying to make is that there is so much redundancy built into this system that we might see some degraded performance if we see a number of failures or specific failures, but the system will stay up, and you will have the opportunity to actually migrate the workloads from one site to another in order to decrease the latency and increase the throughput and whatnot. So essentially, if something happens on the left-hand side, if the filer head on the left-hand side went down, these files will be served from the filer on the right-hand side, but then any virtual machine running on the left-hand side would have to take the WAN path to go access its disk, and you can actually migrate them. You can migrate the hard disk. I mean, you can use VMware vMotion just to migrate both the virtual machines as well as your disks, so that you can actually reduce the latency for any of the critical applications. Now we move on to our last section, which is the management section. Flexpod, every component of the Flexpod, the compute as well as the storage, I mean, we have local managers. We have the UCS manager, which kind of provides you a single pane of glass to manage not only your B series but also your C series servers. We have the Netapp management software, which allows you to create the LUNs or any data stores which you need, as well as lets you expand, grow volumes, whatever you need, right? But at the same time, what we wanted to highlight was, I mean, all these managers actually have extensible management APIs, which could be used by a northbound system to manage this system as one. Right, so single pane of glass through which you can manage your compute network as well as your storage. One such system is the UCS Director, which is the new name for Cisco Cloudpia acquisition. You could use UCS Director. It talks to both UCS Manager as well as the Netapp software. It talks to the VMware vCenter. It talks to our Nexus switching devices, and utilizing the workflows, defining yourself or predefined, you can actually deploy services, add tenants, increase and decrease the volumes. I mean, anything and everything you want. You could do that either through the packaged scripts or through the workflows which you can create yourself. UCS Director not only allows you to deploy, but I mean, from day-to-day basis, I mean, you can keep an eye on your servers as well as your storage and network devices. And I mean, using the data which UCS Director provides, I mean, you can do the future planning. I mean, if some of the components are running really high CPU and hot, you can always make the changes as appropriate as needed. References as promised. If you have any general questions about the design, as well as any FAQs, what is a Flexpod, what's not a Flexpod, Cisco Netapp support site is great for that. All the design guides and all the designs which I have touched in this presentation earlier, these are the direct links to the Cisco validated designs for those. These are the deployment guides. As I mentioned earlier, you can just pick up a document, go line by line, and when you're done with that document, you would have a working Flexpod available to you. The only thing which is not there today, and we are targeting end of October, which is the next month, that is the Nexus 7000 based multi-site Flexpod. The validation is complete, the CVD is under writing, and it's going through the corporate edits. If you have any immediate questions on this design, you're more than welcome to actually ask them now or to ask the expert forum. But the validated design actually will be out towards the end of October. I guess with that, we come to the question and answer, and I guess I'll hand it over to Dan.
Great. Thank you, Haseeb. Just want to remind everyone that although we are in the Q&A section, you still do have some time to submit your questions if you do have any. Let's get started with our first question. Are there any differences in Flexpod and vBlock solutions except storage vendors? Both use the UCS and both use the 5K, etc.
So that's a good question. The idea and the concept is very much the same. I mean, the storage vendors are different. But then again, I mean, vBlock, from my understanding, it's a little bit more stringent. I mean, you have to have a defined vBlock, defined set of configuration, and as well as the hardware and software, whatnot. Flexpod, on the other hand, is much more flexible, as the name suggests, as I mentioned earlier, right? I mean, we let you pick and choose. As well as, I mean, it's more of we providing you most of the time a validated guide based on your input in the Flexpod solution, and we give you the flexibility to mold it the way you want to mold it. So, I mean, there are, I know these are subtle differences. In general, the idea is the same, but I mean, there definitely are, the way we approach the problem is slightly different.
Excellent. Okay, let's go to our next question. What is the performance improvement over Nexus connectivity with FI and Netapp with FCOE compared to FC connectivity?
So some of the performance parameters, I honestly don't know if we have done any specific study on the infrastructure side. The obvious things which come to mind are, I mean, FCOE links are faster. I mean, you have 10 gig FCOE compared to the fiber channel, 4 gig and whatnot. But what I'll do is, if David is unmuted, I'll let him see if Netapp has done any studies, FC versus FCOE. I personally don't know of any.
We don't have anything specifically around performance with each protocol. We have done some testing, and the performance is about equal. But like Haseeb said, we do have a distinct, once we get into the 40 gig and 100 gig Ethernet, obviously there's going to be some differences there. Today, 8 gig fiber channel versus 10 gig FCOE, it's probably a wash in most cases.
Great question. Let's go on to another one. Will Multisite Flexpod Architecture support the VMware SRM 5.x for disaster recovery?
So for the for the Multisite solution, we are not targeting the SRM, Site Recovery Manager, at the moment. I mean, the idea for us is it's more of a disaster avoidance than disaster recovery. So as I mentioned in my discussion, we want to use the metro cluster. We want the ability to move the workload from one site to another site. But I mean, there's nothing to say that if you actually start using the SRM on it, I mean, it won't work, but that's something which we don't validate. For us, as I said, I mean, we use it as an avoidance technique more in this phase. Maybe in future phases, we probably would look into the disaster recovery, and that's where the SRM would come into picture.
Okay, great question. Here's another one. Does MDS 9148 required for the multi-site Flexpod cluster?
It definitely is, and that's essentially that's a configuration for metro cluster which Netapp kind of dictates. They have validated it with 9148. And there is a specific configuration. I mean, let me put it this way. Even though MDS is a Cisco switch, when we work with Netapp, I mean, they are the ones who configured the 9148s, and I don't even know how it was configured, honestly. So it's a required component of the metro cluster, and that's why it's part of the solution.
And just to add to that, something, the MDS switches in this particular configuration are purely for back-end traffic between the two sites for storage only. This is not the front-end connectivity that you connect into these storage controllers with. So even though you might use fiber channel on the back end, that's what we use from the Netapp perspective, you could still attach to your controllers from your clients using FCOE, using fiber channel, using iSCSI, NFS, or SIPs.
Okay, let's get to our next question. How does vMotion occur if the data store is not moving quickly?
So that's a good question. I think I still have the bar. Let me just move back a little. Okay. So for vMotion, as I mentioned, I mean, typically, if you follow the VMware's VMSC design guidelines, you wouldn't want to vMotion. You would want to define your virtual machines on and tie them to a particular data center, and that's where the disks sit, right? But in case of, there might be specific reasons when you want to actually do that. So in cases where you actually have to perform the vMotion, your virtual machine will be migrated from the left data center to the right data center, and it will still be accessing its disk over the WAN link. Definitely not ideal, but I mean, as we all know, the memory moves much faster than the disk itself. So for that duration, the VM will keep on working, but the traffic will be going back and forth between one data center and the other data center, and you would have to incur that latency which is there. Now you can start your storage vMotion at the same time and move the disk to the right-hand side. I mean, if you were doing some sort of maintenance on the left data center, and once that's complete, basically you will start accessing it locally in that data center. So I guess that's the long answer to saying that if the VM moves from one data center to the other, it will use the link between the two data centers to actually keep on accessing its disk till the disk actually moves to the other data center.
Okay, great. Next question. Are there any restrictions or issues when using Violin instead of Netapp?
When using, I'm sorry?
Using the Violin instead of Netapp.
I honestly am not familiar with the Violin. Is that a vendor?
Yeah, it's a storage vendor.
So I'll take my first shot at it. I mean, Flexpod Netapp is an integral component of Flexpod, right? I mean, all the validation which we do here under the Flexpod team is basically done on Netapp. So when we do this validation, I mean, we run into a number of issues, and I mean, God knows the number of issues which we faced before we actually put out a CVD. And we work very closely with the Netapp engineering team to kind of work around those issues. And like in any other multi-site solutions, I mean, the people who are doing it, they probably know it much better than I do. I mean, there are a ton of issues, and you definitely need them to be resolved at all the different layers, switching layers, and as well as the compute, as well as the storage layer. And we validated that with Netapp. We haven't done any validation with Violin, or for that matter, any other storage vendor. So, I mean, I probably won't be the best person to answer that question. But, I mean, one thing which I do want to point out, I mean, validated designs definitely have an edge where most of the issues, I mean, you will run into issues. There's no one denying it. But, I mean, a lot of issues are already ironed out, and we just iron them out only with Netapp and not with any other vendor.
Great. Here's our next question. Will the UCS director provide any ready configurations for Flexpod based on CVD, like a day one config for a quick configuration?
Very good question. And I probably should have mentioned UCS director in this presentation. So we are currently working with the UCS director team, and they can do the day one, day two kind of stuff. And what they have told us is that in one of their future releases, they are actually coming out with the day zero configuration as well. I mean, that was basically their Cloud Ignite platform. They will be integrating that as part of the UCS director. So if you guys hang tight, essentially UCS director will be able to actually support both the day zero as well as the day XYZ configuration.
Okay, great. I don't see any more questions from our audience, so I think we're going to move ahead and close out the Q&A section. In case anyone does have any additional questions, or you've come up with something after the event, Azib will be running an event in the support community and the Q&A forum as part of this webcast, where he'll be answering additional questions over the next 2 weeks. And that will be taking place on starting today through the 27th, and you can follow this link here. That will be also in the PDF, or you can just head over to the Cisco support community and look for this event. We'll also be posting the on-demand version of this recording as well as the Q&A text as well. We do want to give a moment to everyone to pick out the answer to the trivia question, what do Ford Motors and Flexpod have in common? Take a minute to look those over, and we'll get to the answer here in just a minute. And of course, we do appreciate your feedback today. You will see an evaluation survey pop at the end of the WebEx. Please do fill that out, and you will also be entered into a raffle to win a $50 Amazon gift card. A couple of housekeeping slides for upcoming events. Upcoming in October, we have an event in Portuguese covering data center virtualization fundamentals. It'll be on October 3rd. We have one coming up in Russian, Cisco ASR 9000 series aggregation services router, platform architecture, and packet forwarding troubleshooting. All of these registration links are being put up into the chat as well. We have some current events going on right now on best practices for implementing cryptographic VPN, as well as managing controllers with Cisco Prime. A few upcoming events here. Still facing challenges of designing, deploying, and troubleshooting wireless networks, configuring and troubleshooting BGP, and wireless LAN security. We also have something new, a Google Hangout, that's going to be an introduction to Cisco on-demand solutions. Please be sure to check that out. And of course, you can find the support community across all the top social networks. Please do check it out. And of course, at the main website at https://supportforums.cisco.com. We can also find many different languages such as Spanish, Portuguese, Japanese, Polish, or Russian. Just as a reminder, it is free to join the Cisco support community, where you can find plenty of documents, blogs, videos, and other Ask the Expert events going on. You can now rate the content on the support community on a 5-star rating. You can rate the videos, documents, and blogs, and the contributors will receive points. Don't forget, we do have an app as well for the Cisco Technical Support mobile community. And here is our answer for the trivia question. And the correct answer is C. On July 30th, the founder of Ford Motor Company, Henry Ford, was born, and on July 30th, 2013, Cisco and Netapp broadened the Flexpod portfolio with new validated designs across the entire portfolio. I want to thank everyone for your participation today. Thank you to our expert, Hazib, for his time and his presentation. And we'll see you next time. Have a great day.